to Utkarsh Minds Python for Data Science. Today we will see how in Python programming language we can write the hypothesis test for one sample scale data. Scale data is data that is numeric. So for Python I will type collab.research.google.com and I will create a new notebook. Then I will, once my notebook is created, I can give a name here saying scale and connect it, and then I can click on this folder icon at the left and upload my data file. Name of the file that I will need is GSS 2012 a.csv. Once the data is uploaded, so for this, once the data is uploaded, we can read the data in Colab. First I will have to import the Python package. So import pandas package, and then from this pandas package, this read CSV function, which will, then I will type the name of the file and that will give me my data. Next, from the data I will extract the column which stores my scale variable. So scale variable, I will create a variable, and then from data I will select the column age and I will drop any null values that were present. Further, I will also have to do one more pre-processing, that is, from the data I will replace any string values that are present. So if you can also do the same steps. There are certain string values present, I know because I have worked with this data. So these string values I will replace with an integer. For example, the string value 89 or older I will replace with the number 90. With that I have concluded the pre-processing part of my test. Now I have got all the data set in numeric form. I will start with my hypothesis testing. So from scipy.stats import the t-test underscore one sample. So this is the format for the t-test, and here in the arguments I can pass my scale variable, and the t-test, it aims to find out if the scale variable has an average equal to or has a mean value equal to a hypothetical mean. So I will pass the parameter 45. So I am testing if the value is equal to a hypothetical mean, which is 45. The research question is that the average age of the population is 45. So the null hypothesis is the average is not different from 45, and the alternate hypothesis is the average is different from 45. Always the null hypothesis will be that there is no effect or no difference, and the alternate hypothesis is the opposite of the null hypothesis. That is, we have to then launch our t-test, and if the p-value is less than 0.05, that means we will conclude that null hypothesis is rejected. If the null hypothesis is rejected, that means the average is different from 45, but we don't know how big is the difference. So for that, there is an effect size which we will see in the next video. That effect size is the Cohen d effect size. For now, we will launch our t-test on our data. So there is an error. There are some string values present in the data. So I will have to do one more pre-processing step. I will have to convert the string into integer values. So for that, there is a ready-made function which I will use, which is toNumeric function. For that, I will write pandas dot toNumeric. This toNumeric will take as input my scale variable, and it is giving me that statistic and p-value for the test. So the p-value is 0.01, which is less than 0.05, and that means we can safely reject the null hypothesis. As I explained previously, p-value means what is the probability of the null hypothesis being true when we are rejecting it. So the probability, there is only 1% chance. So when I multiply this p-value with 100, I will get 1%. So there is only a 1% chance that the null hypothesis is true when we are rejecting it. For 1%, we don't have to think about this. This 1% is the false positive percent or risk. So this is so small that we don't have to worry about making a false positive. We can safely reject the null hypothesis and conclude that the average is different from 45, which we have assumed is the hypothetical mean of the data. The more different we go, I mean, we can also say that what if the hypothetical mean is 43. In that case, what will be the p-value? So the p-value is even less. So that means we can safely reject that the hypothetical population mean is not 43. It is different from 43. So in this way, you have seen the one sample t-test, which tells you that given a sample, how likely can you make a conclusion about the population. That's it for this video, and the next video we will talk about the effect size. Effect size means there is a difference, but how big is or small is that difference. We will see that in the coming video. Thank you.